Now look at this exercise 105. A box contains the following 4 slips of paper, each having exactly the same dimensions. 1 win price 1, 2 win price 2, 3 win price 3, and 4 win price 1, 2, and 3. So we have 4 slips of paper. Win 1, win 2, win 3, and win 1, 2, 3. One slips will be randomly selected. Let A1 is win price 1, A2 is win price 2, and A3 is win price 3. So we have 3 different events. A1 win price 1, A2 win price 2, A3 win price 3. So what are the probabilities of A1, A2, and A3? We want to calculate probability of A1, probability of A2, and probability of A3. Winning a prize 1. In these two cases you will win prize 1. So the probability of winning prize 1 is 2 from 4 possible slips. So if you choose slips 1 or slips 4, at the end you will win prize 1. So similar for the same for A2. For winning prize 2, the second slip or fourth slip. So again we have is 2 divided by 4, and for the winning prize 3, again the same, slip 3 and slip 4, so it's 2.4. So the probability of A1, A2, and A3 is 1 divided by 2. It says show that A1, A2 are independent. So we should obtain the probability of intersection of A1 and A2. The probability of A1 intersection A2. So A1, A2, it means win price 1 and price 2. Okay, in one case you will win price 1 and price 2 if you choose a slip 4, this one. So the probability is 1 divided by 4. So for proof the independency, we should show that the probability of A1, A2, if it's equal to probability of A, probability of B. So it's 1 and probability of A is 2. You can see that they are equal. So A1 and A2 are independent. They are independent. The second one, A1 and A3 are independent, A2 and A3 are independent. You can see again the probability of A2 and A3 again is in one case you can win both prize 2 and prize 3, and is just picking slips 4. So it's 1 divided by 4, and again for winning prize 1, both prize 1 and both prize 3. So there is only one outcomes, and it's slip 4. So again the probability is 1 divided by 4. So again you can see that the probability of A2 intersection A3 is the product of the probabilities of A2 and A3, so they are independent, and also for A1 and A3. But here, however, show that the probability of A1, A2, A3 is not equal to probability of A1 times probability of A2 times probability of A3. So what is the probability of A1 and A2 and A3? It means winning prize 1 and prize 2 and prize 3. So again there is only one possible outcome. It's picking slip 4. So the probability is 1 slip from 4 possible slips. So but the product of the individual probabilities of A1, A2 and A3 is not equal to the probability of intersection A1, A2 and A3. So A1, A2 and A3 are not mutually independent, but they are pairwise independent. Now look at exercise 70. Suppose that the proportion of blood phenotypes in a particular population are as follows. 42% of populations are A, 10% B, 4% AB, and 44% O. Assuming that the phenotypes of two randomly selected individuals are independent of each other. Look at here, you can see the keyword here, independent. What is the probability that both phenotypes are O? So we have two randomly selected individuals, and we want to calculate the probability that both of them are O. So it means the first one is O and the second is O. And these two events, I can show these events with O1 intersection O2. They are independent according to the question. So the probability of O1 intersection O2 is the probability of O1 times probability of O2. So the probability of O is 44%. So it's for the first one is 44%, and for the second one is 44. Now, what is the probability that the phenotypes of two randomly selected individuals match? It means they have the same phenotypes. So It means both of them should have O or both of them should have AB, again, or both of them should have B, or both of them should have A. So the probability is, because they are independent, so the probability is 44 times 44. Then for A, 42 times 42 plus. For B, 0.1 times 0.1. And for AB, 4% times 4%. And the result is 0.038. So two individual matches means that both of them, the first one O and the second one O, or the first one A and the second one A, or the first one B and the second one B, or the first one AB and the second one AB. But because these events are independent, so the probability of O1 intersection O2 is the probability of O1 times probability of O2, or the probability of B1 intersection B2 is the probability of B1 times probability of B2. Now look at exercise 68. In exercise 50, is any AI independent of any other AI? Answer using the multiplication property for the independent events. Okay, what is exercise 50? A consulting firm presently has bids out on 3 projects. Let AI is awarded project A for A1 to 3. So the probability of A1 is 0.22, A2, A3, and we have the probability of A1 and A2, A1 and A3, A2 and A3, and A1, A2 and A3. Now we want to see if they are independent or not. A1, A2, the intersection is 0.11, but the probability of A1 times probability of A2 is 0.22 times 0.25, and they are not equal, so A1 and A2 are not independent. For A2 and A3, the intersection, the probability of intersection is 0.07, but the probability of A2 times probability of A3 is 0.25 times 0.28, and the result is 0.07. So A2 and A3 are independent, but for A1 and A3, the intersection probability of intersection is 0.05. The product of the probability of A1 and A3 is 0.06, so they are not independent. So in total, A1, A2 and A3 are not mutually independent, because we already showed that this one or this one are not valid. Now look at exercise 67. An oil company currently has two active projects, one in Asia, another one in Europe. Let's A be the event that Asian project is successful and B the event that the European is successful. And suppose A and B are independent. It's the keyword. Look at here, A and B are independent. And the probability of A is 0.4, the probability of B is 0.7. A, if the Asian project is not successful, look at here, if, it's a conditional probability. What is the probability that the European project is not also successful? Explain your answer. Okay, A is the events that Asian one is successful. B is the European one is successful. So A prime, it means Asian is not successful, and B prime is the European one is not successful. Now, if the Asian is not successful, what is the probability that European is not successful? Okay, if the Asian is not successful, what is the probability that the European is not successful? From the question, we know that A and B are independent. And you know that when A and B are independent, then A prime and B prime are independent. So when A prime and B prime are independent, it means A prime doesn't have any impact on B prime. So the probability of B prime given that A prime is the probability of B prime. So it's 1 minus probability of B, and the probability of B is 0.7. So the answer is 0.3. So again, when A and B are independent, then A prime and B prime are independent. So A prime doesn't have any impact on B prime. So that according to the definition of independence, the probability of B prime given by A prime is the probability of B prime. The probability of B prime according to the proposition 2 is 1 minus probability B, so is 1 minus 0.7 is 0.3. B. What is the probability that at least again keyword, at least, it means at least one, it means one or both, because here we have two projects. At least one of the two projects will be successful. Okay, at least one of the two, it means one or both of them, and it's the keyword for union, because in union, A union B, it means A or B or both of them. So the probability of A union B, it means the probability of at least one is successful. So the probability of A union B is the probability of A plus proposition 4 B minus probability of A intersection B. But because A and B are independent, then the probability of A intersection B is the probability of A times probability of B, or here. So the answer is probability of A is 0.4, the probability of B 0.7 minus product of probabilities of A and B. So the result is 0.82. Number 3, given that, again a conditional probability. All of these words are keywords. Please be careful about these keywords in the question. Given that at least one of the two projects is successful, it means given that A union B, what is the probability that only the Asian project is successful? Only, again, is keyword. Only Asian project is successful. It means A minus B. So again, at least one of them successful is A union B. Only Asian is successful is A minus B, or A intersection B prime. We talked about all these equations before. So now we are going to calculate this. What is the probability that only Asian is successful, given that at least one of them were successful? Now how we are going to obtain this is the probability of A intersection B intersection A union B divided by probability A union B. We have the probability of A union B from parts B. Now what is this probability of A intersection B prime intersection A union B? If you look at this Venn diagram, A union B is this part. So this yellow part is A union B. just A is this part. It's just A minus B, or A intersection B prime. Now, according to this Venn diagram, A intersection B prime intersection A union B is A intersection B prime. You can see that the intersection of yellow part and red part is red part. So here we have, it's the probability of A intersection B prime, probability of A union B. A union B is 0.82, but because A and B are independent, again A and B prime are independent. Again, please listen to me. According to the question, we had that A and B are independent. So when A and B are independent, A and B prime are also independent. So we can write the probability of A intersection B prime is the probability of A, probability of B prime. So is 0.4, and B prime was 1 minus B is 1 minus 0.7 is 0.3, and the result is 0.146.